Good morning, students. Welcome back to science class on the chapter motion. In the previous class, we had discussed about average speed and velocity. Okay. Uh, Today we will start our class with simple problem. Okay. First, I will write the problem. See. Usha swings in a 90-meter long pool. A 90-meter long pool. So she covers 1 meter in 1 minute. 1 minute by swimming from one end to the other and back back along the same straight path. Straight path. Find the find average speed and average velocity of Usha. Okay. See here. Usha swims in a 90-meter long pool. Okay. So just imagine one pool. Okay. Swimming pool. And say it is 90-meter long. The distance from this end to this end is 90 meter. Okay. Next, the other. See here, she covers 180 meter. She covers 180 meter in 1 minute. She covers 180 meter in 1 minute by swimming from one end to the other. Okay, she will swim from one end to other, but she will cover 180 meter. Okay, the length of the pool is 90 meter. She will covers 180 meter. Okay, just imagine this is her starting point, Usha's starting point A. Okay, and this is another end B. Okay, next back other and back along the same straight path. And see, first she will travel A to B, then she will swim back along the same straight path. Totally, she will cover 180 meter in 1 minute. So, total distance is 180 meter. And what about time? Time is 1 minute. So 1 minute means 60 seconds. Okay, 60 seconds. First, calculate the average speed. Average speed is equal to total distance divided by total time taken. Okay. So what is the total distance here? So total distance is 180 meter. What about total time? Total time is 60 seconds. 0 seconds, then 3. Okay. So her average speed is 3 meter per second. Okay. So first she will started her journey from A. After 3, sorry, she will travel A to B and B to A with the average speed of 3 meter per second. Okay. Next, what is average velocity? See here we can clearly say that average velocity is 0. Why? Because see, starting point A only and ending point A only. So what is the displacement here? So displacement is 0. 0 by anything is 0. So average velocity of Usha is that is 0. Okay. Uh, Next we'll discuss some more important problems. Okay. Exercise problems. See, an athlete completes one round of a circular track of diameter 200 meter in 40 seconds. So what will be the distance covered and the displacement at the end of 2 minutes 20 seconds? Okay. So one track is there and that track is in the shape of circle. Okay. So it is a circular shape and they have mentioned what the diameter of that circular track is 200 meter. Diameter is 200 meter. So clearly we can say that radius of that circular track is 100 meter. Okay. So just imagine that athlete will start his journey at A. This is the point. This point is A and this point is B. Okay. See, an athlete completes one round of a circular track. He will complete that complete round. Okay. He will take 40 seconds to complete one round, which means just imagine he will start his journey here. Okay, so he will travel here, and here to reach A. He will start at A and to reach A means to complete one round, he will take 40 seconds. 40 seconds, which means in 40 seconds he will complete one round. Okay, and the circle of say diameter of that circle is 200 meter. So here, what is the question? So here they ask, what will be the distance covered and the displacement at the end of 2 minutes 20 seconds? If suppose if the question at the end of 40 seconds, his distance is, we can say that, see, we can calculate easily, means one round. Okay. Now, but here we need at the end of 2 minutes 20 seconds. Okay. How to calculate? So here we need this length of the circle, right? Okay. So we need to see that athlete will travel using this path. Okay. So we should calculate the length of this circle or boundary of the circle. Okay. See here, if the circle is very small, okay, if the circle is very small, easily you can calculate the length of the boundary of the circle. See here. So take one thread. Here I am using wire. Okay. If the circle is very small, see, just a stretch like this. Okay, just you adjust the points like this. Okay. So then you can stretch like this, make it straight. Then you can calculate the length easily. Okay, using your scale. So now it is in the circle shape. Okay, now it is in the circle shape. Using scale, stretch like this. Then you can measure. If the circle is very small. If the circle is very big, just like your city, so at that time, is it possible to taking a thread and measuring? It is difficult, right? So for that, we have one formula. Okay, if you know the radius of any circle, we can calculate the length of or boundary of the circle. Okay, so we call it as circumference of the circle. That is C is equals to 2 pi r. Okay, we use C here. C means circumference of circle. Circumference. To calculate this circumference, we use this formula. Okay, 2 pi r. If you know the radius of any circle, whether it is a small or big, whatever, so then we can calculate the circumference of the circle or boundary of the circle. Means this boundary. Okay. Yes. See here. First, we can calculate how much the circle is big, the circumference of the circle. So first, see here. Listen here. He will start at A. Okay. He will draw like this, and finally he will reach here. So now that athlete covered this distance, right? This distance, this distance. Okay. So now this distance is equals to what? That is circumference of circle. Okay. So now so d distance is equals to 2 into pi value means, you know, right, 22 divided by 7 into what is the radius of circle? Here they have given, right, diameter is 200. Then what is the radius of the circle? Radius means it is half of the diameter, that is 100. Okay. So now how to calculate this one? Simple, right? First multiply 44 into 100 divided by 7. Okay, so then multiply 7. Okay, so distance is equals to 4400 divided by 7. Clear? So now I will write direct answer. Okay, 658.57 meter. Okay, so length, circumference of this circle, circumference of this circle means the length. Okay, so that is 658.57 meter. Clear? So circumference of the circle is 658.57 meter. Okay. So now that athlete, okay, he will complete this distance. This distance. Why? Because here they have been right. An athlete completes one round. So now here one round is equals to 658.57, right? Because this circumference length of the that boundary of that circle, that is equal to 658.57 meter. So that's why here one round is equal to 658.57 meter. Okay, so one round is equals to 658.57 meter. Next, here he will complete this distance. Okay, he will cover 658.57 meter distance in 40 seconds. In 40 seconds. Then what will be the distance and displacement at the end of 2 minutes 20 seconds? Okay, at the end of 2 minutes 20 seconds. Here, so in in 40 seconds he will cover 658.57 meter. Okay, see here we need at the end of 2 minutes. 2 minutes means 120 seconds. 2 minutes means 120 seconds plus 20. So that is total 40 seconds. So what will be the distance covered and displacement at the end of 140 seconds? At the end of 140 seconds. In 40 seconds, he will cover 658.57 meter. Then what about in 140 seconds? Simple one, right? So now 140 into 658.57 divided by 40. Okay, so now this is the distance at the end of 2 minutes 20 seconds. Okay, here we are calculating the distance covered by that object at the end of 2 minutes 20 seconds. We have converted this 2 minutes into 2 minutes 20 seconds into 140 seconds. Clear? Okay. So now this distance equal to 140 into 658.5740. So now this answer I will give you homework. Okay, message me what is the answer for this question. Clear? Next, what will be the displacement at the end of 2 minutes 20 seconds? If you want to calculate what displacement, here you should know the starting point and ending point. Clear? For to calculate to calculate distance we don't want. Okay, just we need the actual path. But here see in distance also we need starting and ending point, but while calculating displacement we need starting and ending point. Okay, so he started his journey at A. Okay, so where is his final position? At the end of 2 minutes 20 seconds. Okay, see total 140 seconds. Total he will travel 140 seconds. You know they have given right. In a completes one round of a circular track in 40 seconds. He will complete one round in 40 seconds. Okay. So what about for second round? He will complete the second round in 80 seconds, right? Okay. First one round 40 seconds, second round 40 seconds, but what is the total time? That is 80 seconds. In the third round, in 120 seconds, he will cover 3 rounds. But see, that athlete traveled only 140 seconds. So now, after 120 seconds, he will cover 3 rounds. So now we need only 20 seconds, right? Okay. So see here. Now first you will start here. After 1 second, 40 seconds are over. 40 seconds are over and one round is completed. Next once again. So total 80 seconds are over. So now here 2 rounds are over. Next, once again, one for 120 seconds. So total 3 rounds are over. After 3 rounds, his position is here only. After 3 rounds, so total time is 120 seconds over. So now remaining we need only 20 seconds. In 40 seconds, he will complete one round. What about in 20 seconds? So in 20 seconds, he will complete only half of the circle, right? So after 140 seconds, his final position is at B. Okay, clear? See here, in 40 seconds, he will complete one round. In 80 seconds, he will complete two rounds. In 120 seconds, he will complete 3 rounds. After 3 rounds, his position is at A only, but he traveled only 140 seconds. 140 seconds. So 120 seconds time is over. Clear? So now after 20 seconds, his position is at B. Okay, total he will complete 3 rounds and 3.5 rounds. Okay, 3.5 rounds. So he will cover that 3.5 rounds in 140 seconds. Okay, but his final position is at B. Started at A, ended at B only. So now what is the shortest distance between A and B? Okay, so the shortest distance between A and B is 200 meter, because this is the shortest path, right? So now this shortest path is equal to the diameter of the circle. So that's why displacement is equal to 200 meter. Displacement is equal to 200 meter. Clear? So I have given homework that distance. Okay. Hope you understood this problem. Simple one. So next move to third one. So now this is your exercise first question. So now I will discuss second question. Okay, from your exercise. See here. So now, here, Joseph jogs from one end A to the other end B of a straight 300 meter road. Okay. So here one road is there. Okay. So now just draw one rough diagram. Okay. So straight road, right? They are mentioned, and I will call this is A and this is B. Okay. Next, here they mentioned straight road and of straight 300-meter road. Okay. The distance from A to B is 300 meter. Then road in 2 minutes 30 seconds. So Joseph jogs one end A to the other end B, which means he will travel from A to B and he will cover 300-meter distance in 2 minutes 20 seconds. He will cover 2 minutes, sorry, 2 minutes 30 seconds. 2 minutes means 120 seconds, then plus 30, that is 150 seconds. In 150 seconds, he will cover total 300 meter. Which means he will travel from A to B. Clear? Next, and then turns around and jogs 100-meter back to point C. And see, they have mentioned clearly what? And then turns around and jogs 100-meter back to point C. Okay, so you will travel like this, then you will turn and return, or turn around along, and he will travel along the same path and recovered and reaches point C. It takes C. So while coming back, so he covered, that is say 100 meter. Here they are given, right? Okay. Next, in another 1 minute, in another 1 minute, first he will travel A to B in 150 seconds, then he will travel B to C in 1 minute, that is 60 seconds. So what are Joseph's average speeds and velocities in jogging from A to B, and second question from A to C. So now first we will discuss first one, A to B. A to, yes, we know the formula. Average speed is equal to total distance traveled divided by total time taken. What is the total distance? See, first question A to B, right now. So A to B total distance is 300 meter. 300 meter. So total time taken from A to B only, that is 150. So what is the answer? That is 2 meter per second. Next, calculate velocity. Velocity is equals to displacement divided by time taken. So what is the displacement from see, starting point is A and ending point B. What is the shortest distance? Shortest distance is 300 meter. Okay, 300 meter. Then what is the time taken? Time taken also same, right? That is 150. So answer is 2 meter per second. Clear? The answer is 2 meter per second. Okay. So first one is over. A to B. So average speed equal to total distance divided by total time taken, that is 2 meter per second, and velocity is 2 meter per second. Why? Here both are separate. Why? Because the distance covered arc is because it is a straight line path. Okay. So next move to second case from A to C. A to C. So once again, average average speed equal to total distance traveled divided by total time taken. So what is the average speed? Sorry, what is total distance from A to C? See here, first A to B. See, what is the actual path? Don't take from A to C, because A to C is not actual path covered by that Joseph. Okay, Joseph's actual path is first A to B, then B to C. Okay, first A to B, that is 300, then B to C. Okay, because first A to B, then B to C. This is the actual path of Joseph's. Okay, not from direct A to C. First A to B, that is 300, then B to C, that is 100. 300 plus 100. So total distance is 300 plus 100. What is the total time taken? Total time taken. First A to B 150 seconds, then B to C 1 minute, that is 60 seconds. Clear? So total time is 150 plus 60. So what is the answer? That is 400 divided by 150 plus 60. That is 210. Okay. So now this is 0 0 get cancelled. Just divide 40 divided by 21. What is the answer? 40 divided by 21. So that is 1.9. I write down directly 1.9 meter per second. Okay. So 1.9 meter per second. Now second, well, what is the velocity? Velocity is equal to displacement divided by time taken. So what is the displacement? So starting point is A and ending point is C. Then what is the shortest between A to C? See, now here don't take from A to B, B to C. Okay. So now we need displacement. Displacement means what? That is shortest distance. So shortest distance between A and B is 200. Why? Because here 300 and here 100. We need this distance. So 300. So now the displacement from A to C is 200 meter. Okay, 200 meter. What is the time taken? See, time taken same from first to 150 plus 60. That is 2 times. Is 2 times. There is a cancel. Now just divide 20 by 21. Definitely you will get the answer less than 1. I think that is 0.9 something. Okay. Yes, the answer is 0.95. 0.95 meter per second. So this is the velocity. Okay. Yes. Yes. So now we'll discuss next one. See, Abdul, while driving to school, computes average speed for his trip to be 20 kilometers per hour. On his return trip along the same route, there is less traffic and the average speed is 30 kilometer per hour. What is the average speed for Abdul's trip? Okay, so now draw a rough diagram. Say this is point A and this is point B. See, you will travel from home to school, right? Okay. So now I take his home is at A position and his school is at position B. Okay. He will travel with average speed from A to B. Okay, that is 20 kilometer per hour. 20 kilometer per hour. Then while coming, see, he will return along the same from B to A. So due to the less traffic, he will change his speed. Means he will increase his speed. Say that is 30 kilometer per hour. Okay. So count what is the average speed for Abdul's trip. What is the average speed? We know the formula. Average speed is equal to total distance traveled divided by total time taken. Okay. So here we don't know. Okay, here we don't know what is distance, what is total distance, and what is total time taken. Okay, but how to calculate that average speed? Just observe here, while traveling from A to B and B to A, something is same. He will return to his home along the same route, right? Just imagine A to B, the distance is say 3 kilometer. Then what about distance B to A? 3 kilometer only. Okay. So now here I don't know the distance. I will take the distance traveled from A to B as X. Then what about B to A? X only, right? Okay. Yes. So now here the distance from A to B X, then B to A is also X. Why? Because same distance. Because he returned along the same route. So that's why the distance from A to B to A is also equal to X. Okay. Next, what about the time? Here distance same. Do you think that the time is also same? See here, distance is same. If the time is also same, then it is impossible, right? This is 20 and 30, then the speed it should be equal. Okay? If the distance are same, if the times are same, then there is no distance in 20, there is no distance in average speed, then you will get the same speed. So due to the change in time, the speeds are different. Here because they are mentioned because you will travel A to B then B to A. The distance is same. We can clearly say that distance traveled is same. Going and while returning back to home. But time is not equal. If the time is equal, then that what speeds are also equal. Here they are given, right? Speeds are different. Okay, speeds are different. Okay, but the times are not equal. So now I will take first. See here, first I will give you clue. This I will give homework for you. First I will give clue. See here, first yes, A to B. A to B. The distance covered from A to B is I will take it as X. Distance equal to X. What about time taken? I don't know, right? So A to B, I will take that time taken as T1. T1. But here, what is the speed from A to B? That is 20, right? Okay, I will write speed equal to 20 kilometer per hour. So now see here, now first case A to B. So we know the formula, that is speed equal to distance by time. What is the speed here? That is 20. What is the distance? Distance is x. Then what is the time? Time is t1. Okay. So now we can write this as take t1 this side. I will write here. So t1 equal to x by 20. So now here is the division form. If you bring this t1 this side, so now here division. What happens when you bring this side? It will become multiply, right? That is 20 into t1. So now, okay, I will write this step. So now t 20 into t1 is equals to x. So now take 20 side here in the form multiplication. What happens when you bring this side? That is division. Okay. So t1 is equals to x by 20. Call this equation as 1. Okay. See, if you know the x value, then you will get the time from A to B. Here you know the speed only, but you don't know the distance. Okay. If you know the distance, then you will get the time taken from A to B, right? So now this is to take this as case number 1. Next, second one, B to A. Second one, I will take B to A. So what is the distance traveled from B to A? Distance is in x. What about time? See here I told, right, here times are different. You can't take time as t1. So I will take time as t2. Then what is the speed? That is 30. Okay. Distance is 30. So now using once again the same formula, I will just substitute the values here. Okay. t2. Now this is t1 and this is t2. This is 30. Clear? And I call this equation as 2. Okay. If you substitute the value for x, then you get the time taken from B to A. See, first equation, t1 equal to x by 20. Then t2 equal to x by 30. This is equation 1 and this is equation 2. Okay. So time taken from A to B is x by 20. Then time taken from B to A is x by 30. We need average speed. So average speed equal to total distance. What is the total distance? A to B x, then B to A x. So x plus x, that is 2x. What is the total time taken? Total time taken means time taken from A to B, then time taken from B to A. So A to B t1, B to A t2. Just add t1 plus t2. Okay. So just complete this problem. This is homework for you. So I will stop here. Tomorrow I will continue the class.